In this video, I'm going to be teaching you about the difference between variable gauges and attribute gauges. A variable gauge, like a caliper here, gives you a direct reading of what it's measuring. So you're going to get an exact number, for instance, 1.564 in this example. An attribute gauge won't do that for you. An attribute gauge is just going to tell you, did it fit or not? We call this go, no go. And pin gauge, for example, if it fits in a hole, you know that this size pin fits in there, but you don't know how big the hole is. It could be much larger. There's a few different applications for when you want to apply each style, and let's just go through them. We're going to start off with the variable gauges. So as I said, they return a specific number for everything it measures. So calipers, whether it's vernier, dial, digital, are all going to give you a direct number. Every micrometer is going to have that vernier scale on it. So as you take your readings, you'll be able to read the vernier scale here on this mic, on depth mics, hole micrometers, 3-point hole mic here, as well as pretty much any style of micrometer. Indicators, whether it's a drop indicator like I have here, or a test indicator, is going to tell you exactly how far that indicator moved, as well as a steel rule. If you're doing a measurement over wires with a micrometer, it'll tell you the measurement over wires in a direct number, and you can convert that to a pitch diameter and get a direct reading of pitch diameter after the conversion. Protractors for measuring angles, no protractors, CMMs. There's many other styles of gauge that we could talk about, but the key to remember is everything you measure gives you a number. It doesn't give you a go, no go, or a pass fail. It gives you an actual number that you can compare against your requirements, because all of your requirements will basically be defined by those numbers. So an attribute gauge, in contrast, they don't give you a real number out of it. They only tell you whether or not your attribute gauge went in. So for example, with pin gauges, yeah, it goes into this hole here. But yeah, it's much bigger than this hole. Won't go into this hole. Will go into this hole, but not all the way through to the back hole. So it basically tells you whether it fits or it doesn't. And normally I'll take a look at my print here, and I'll say, let's look at this 397 hole. Let's look at our tolerance. We have plus or minus 5 thousandths on our 397s hole for this part here. And so I will say, okay, it needs to be between 392 and 402, adding 5 thousandths, subtracting 5 thousandths from the nominal here. So I'll go to my little pin box, and I'll grab the 392, which is right here, and we'll see if that goes in. Yep, flies through easily. No resistance. Then I'll grab the 402, see if the 402 goes in, and it doesn't even start. So I know that hole size is somewhere between 392 and 402, and that means it passes, but I don't know how big the hole is. If I wanted to know how big the hole is, I could keep grabbing successive pins from 392 to 393 to 394, and I could figure out, within 1,000th how big that hole is, but I wouldn't be able to know it exactly. Even a caliper is not going to give you better resolution than the pin gauges, because the resolution of the caliper is the same as the pin gauges. So I can read that to 1,000th of an inch, and I have pin gauges at 1,000th of an inch increments. So in this case, variable is not going to give you any additional resolution. If we had a hole micrometer in this size, you could get down to the 10,000th of an inch. You could stick it in there. If you had pin gauges that are in increments of 10,000th of an inch, you could do that too. But really, you don't know how big that hole is. Just using the pin gauges, you just know which one fits and which one doesn't. And this style of checking what pin goes in is called go, no-go gauging. So you have a go pin and you have a no-go pin. And basically, one of them should go in, one of them should not. So with a go pin, um, in this case, it was the 392 pin. As long as that one goes in, and the 402 pin, which is the no-go, if that doesn't go in, the hole passes the requirement. Now, if both of them go in, that means the hole is larger than your no-go size, and you've got a problem. And if both of them do not go in, it means the hole is too small, and you've got another problem. So what you're looking for is for the go pin to slide in, and for the no-go pin to stop before it starts to go in. So pins are a great example for this. They come in increments of 1,000th of an inch all the way up from about 11 thousandths to an inch. So you can get about 900, 987 pins, something like that in a set if you want to. If you go above an inch, there's not very much in the way of go, no-go gauging. You can get things custom made. If you want to talk about a slot, like this part has a slot here, we also have Joe blocks. So I'm going to grab the 400 and we'll see if that slides in. It does slide in, which is, if we take a look at our print here, should be a 405 plus or minus 5 thousandths, the same tolerance. So 400 should go. And if we build up a 410 stack, which I will do now with a 300 and a 110, and I'll put these together. And there we go. I'll quickly verify with caliper that I at least grab them correctly. And you can see it doesn't want to start. I can't get this to start in the slot. So that means the slot is within tolerance because my go slot gauge, which again, you verify, this is the 400 size. That goes in just fine. 400 goes, and 410 does not. So it's somewhere between 400 and 410. And, maybe you care about that. Maybe you need to know the actual number, and maybe you don't. That'll be depending on what your, what's your policy for inspecting this part. Do you need to know the slot size? Do you need to record it? Or you just need to know a pass-fail? If you need to know the actual size, well, here's a good opportunity to pull out your caliper, and I can see it's 408. If you take a look at the secondary camera here, you'll see it's reading 408. So let me flip that over right now. Let's redo some of those checks. So I've got the 408, 407 here on the caliper, and I'll grab my pin or my blocks, and we'll see. Look, the 400 goes easily because we know the caliper said it was 408. But what we don't know, let's check if the let's check if the 410 went again. So I'm going to build up my 410 stack. I'm going to crisscross, slide together. I'm going to quickly verify that I grab the right side. Okay, 409. I'm only checking that this 300, it looks pretty much the same size whether you look at it from the side or look at it from the front. So I'm just trying to verify, yeah, I did grab the right one. I would normally always recommend verifying this with a micrometer or an indicator, not a caliper, but for the purposes of this check, using a caliper. And again, once again, does not go. So 410 on the caliper, 407, 408 on the caliper. So obviously our 410 stack's not going to go in. So that's our no-go size. That means it worked just well. That there. So gauge pins are a great go, no-go. So are stacking up blocks. You can stack up these blocks as high as you need to create your go and your no-go stacks. This set goes up to a 4-inch block as the maximum size. So you can stack up quite a lot if you need to. Another great tool, if you're going to inspect the thread on this print, let's take a look at this thread. Has a 3/8/16 UNC 2B thread. Well, the way you're going to inspect that is with a go, no-go thread gauge. So you're going to take a gauge that threads in to this hole. The go should thread in. The no-go should not thread in. It's the same as when you're using the pin gauges. And unfortunately, I don't have that right here to show you, but if this is a good part, you're going to thread in the go side, and then when you go to start the no-go, it's just going to stop. It won't. You might get a little half turn, 1 turn maybe, but eventually it should stop if the thread's good. Now, if the no-go goes in, you're in trouble because the no-go should not go in, and that thread's been cut too large, which means you're going to need some rework, or you're going to scrap the part. There are ways to redo that thread, but it's tricky, and it'll depend on your part. So, but it's a great way to measure the pitch diameter for go, no-go, because, frankly, there's not a lot of other ways to do it. For an internal thread, go, no-go is going to be your best bet. Now on this slide here, I have Joe blocks, flagged as being an attribute gauge, because you can build a go stack and a no-go stack, and that's just like attribute go and no-go. You can also, let's skip ahead, you can also kind of use these, this set almost like a variable gauge if you want to build up the stack until you get the exact size you're looking for. This does go to 10,000ths of an inch, this row here. So this top row has increments of 10,000ths of an inch instead of 1,000. So you can get pretty accurate that way if you really need to, but most of the time you're not going to. You're just going to set up a go, no-go 2 stacks. So now that you kind of know the difference between them, what's better, right? People always want to know, which one should I use? Which method is better? Which technique is better? And really it comes down to a pro-con, which one wins in each situation. There's no clear-cut way to answer that. So let's just go through each of these different comparisons. So first one, which one's faster? Well, using an attribute is usually faster because you're just sticking this in, checking it if it goes in or it's not going. You can almost do that with your eyes closed. Now, I wouldn't recommend that, but that means you can check a lot of parts over and over again with the same go gauge, and you can grab the no-go gauge and check a lot of parts in the same way. So when you have a lot of parts, it can be faster, and even when you just have one part, you got to verify this is zeroed. You got to sit in there, got to rock it back and forth, and maybe you got to take a few measurements, go around it. So I would say attribute gauges are a clear-cut winner if you're looking for speed. And also think about it if you're looking at cost. That's debatable. I put attribute gauges as being lower cost, mostly because this caliper is $100. Individual pin is maybe $10. And so if you're going to get a go, no-go situation, you just need a couple of pins, you're going to pay 20 bucks for this. You're going to pay maybe $100 for a caliper. And when you start talking about micrometers, each one of these hole mics can be very expensive, and it has a very small range. So you get yourself a nice set of gauge blocks, a nice set of pin gauges in the sizes that you need, and over time these are going to last a long time if you treat them well, and they're not going to wear so much, and you won't need to replace them. You will need to calibrate them, but I think overall it's going to be a cheaper investment. Although it's not always, one or the other. Oftentimes you're going to need both in your career and your job. So yeah, wake up my second monitor. As I say, you're going to need both. But I think overall, if you're just looking at a specific feature, if you can do it with a variable go and a no-go, you're probably going to end up spending a little bit less. Which one's more accurate? Well, in terms of the pin gauges and the gauge blocks, if you look at some of the other videos, I talk about how accurate these are with their manufacturing specs. These are manufactured to very controlled specs, more so than the variable gauges. The variable gauges have more error. Oftentimes, they're much larger travel. So when you have a larger travel, there's going to be more error introduced. Even with these whole micrometers, like I mentioned, they have a very small increment, but as you get larger and larger with these things, they get more and more error. So a 2-inch to 2.5 inch is going to have more error than this little one, which I think is 0.8 to 1 inch. So I would say overall, if you're just looking at accuracy, your pin gauges and your drill blocks, any inspection that you use with those as go, no-go is going to be very accurate because of the way these are manufactured, and as long as they're maintained correctly, you're going to be very accurate, more accurate than some of the variable tools. And you'll have to watch some of those other videos. I can't go in full depth here if you're interested. But the trade-off is, the variable get more range of values. You get a limited range with these in some cases. Next one comes down to, well, kind of your business operation. Are you going to use a sampling plan? And both of them have a sampling plan available. So you have a variable plan, Z1.9, and you have an attribute plan, Z1.4. Now, I'm going to talk about sampling in another video, go into more detail with that, but basically there are sampling plans available. If you're going to be using go, no-go gauging, you're going to grab the attribute Z1.4. And if you want to use variable inspection plans where you need an actual number, you might want to follow Z1.9. And as I mentioned, there's another video where I'll talk about sampling plans. That's not exclusive to the gauges, it's more exclusive to the measurement, to the method. So let me fix that real quick. Oh my gosh, what did I do? Okay, sorry about that. When you're talking about sampling plans, as I was saying, it's not exclusive to the gauge. You can use variable gauges in an attribute plan and vice versa. But if you want to kind of, stick to using variable gauges and variable plans, look up these plans. There's some other, and these are the ANSI ASQ ones are not the exclusive. There's more out there. So, but these are the most commonly used in manufacturing nowadays. So write this down, look this up on the internet if you've never heard about these, Z1.9 and Z1.4. 1.4 is a lot more common. So research that if you're going to be doing a lot of sampling in your career, in your job. Next one, data analysis. So kind of goes hand in hand with the sampling. Some companies will track every feature that they record. They want to track maybe how thick this is. It might be something they're tracking closely in production because it's hard to control. Could be critical to the final customer or assembly, an internal process, whatever. And they're going to track each number in a variable sense. So if I grab this, I get 0.998 thickness with my caliper. Well, I could record that for my inspection sheet. And for hole size, you could grab your go size. So 392, I believe, was the go size for this hole. And that one in, Let me leave that out. And 402 would not go in. You can record that as well and do some data analysis. If that one's basically just a pass-fail, and you'll record how many parts passed, how many failed, and you can do some data analysis on that too. So there's different requirements. If you're not sure, you can ask a supervisor, ask somebody who's been there a while. Is the company using this data for anything, or is it more of a record of it passed failed? And there's different applications. Like I mentioned, you can use this to verify your process. If your process is in control, or if it's wildly out of control, and sometimes you can track down what's causing those out of control situations. It could be environmental, it could be manufacturing process related, like wear, but many companies find it very useful, and some require it. So if you're not sure, just ask somebody. So keep going on which is better. Do you record the data at all? So I just went through and said you can do data analysis on go, no-go, which is attribute. This one, you're not actually recording a measurement, right? You're recording a pass-fail when you're doing attribute, but you're not recording the number. So because you're probably going to be at your extreme go side and your extreme no-go side. So in that sense, you're not really recording data measurements, you're recording pass-fail. But with variable, as I said, you are recording whatever size you got on the caliper. So you can get histograms with that, averages, all sorts of nice things from data like that. So again, if you're not sure what you should be doing, just ask somebody. It'll probably be clear, and if it's not clear, I'm sure somebody will tell you. And then it comes down to, well, when do you want to use it? These next four, if you're setting up a process, if you're like, got a new product coming through and you got to maybe buy some tooling, or maybe you've just got to use your time wisely. You're looking at your what you need to get done in the day, and you're saying, oh man, which tool should I use? I've got all these variable gauges, I've got all these attribute gauges that can do the job. How do you decide? A lot of people will just pick whatever they're most comfortable with, and that's a reasonable way to do it. I won't say you shouldn't do that, but I will say you want to get comfortable with everything, strengths and weaknesses of all the gauges. So I would say take a look at your parts, take a look at your tools, and let's go through these examples. So are you talking about low volume? If you're going to do low volume, maybe a variable gauge is fine, just because, yeah, you've already got it. You're going to have a caliper, you're going to have micrometers around. If you're only doing one or two parts, the low volume nature of that will be fast with a variable gauge. But if you had to do a lot of parts, hundreds or thousands, maybe you're doing 100% checks in a high volume situation, well, then it's going to make more sense to get your no-go gauges set up. Like I said, you can kind of almost do this with your eyes closed, which I don't recommend. But it's go, it's no-go, and you just move on from there. So that's great for high volume stuff because you can do all your goes left to right, you can do all your no-goes left to right, pull out the ones that failed that inspection, and move on. Next one, when you're talking about low complexity or high complexity, I would say attribute gauges are great for low complexities, slot width, hole size, something that's got very basic go, no-go qualities to it. So when you look at your print, you'll be able to, get a feel for it. The more parts you do, you'll be able to get some sense for when you should be using a go gauge or an attribute gauge. Sorry, a variable gauge. So I would say high complexity tend to be more oftenly measured with the variable gauges because they'll have a lot of complex numbers around them, like an angle. It's hard to set up a go, no-go gauge for an angle. It could be a flatness or a parallelism. Again, how you're going to do that with a go no-go gauge. So when it gets to high complexity stuff, maybe you're going to be using a CMM just because of the nature of the call out. Right, I got a print here. This is PM3. If you want to check the website for that. And equal spacing. That's going to be hard to do with a go no-go gauge, but very easy to do with a variable gauge. So you can, I would say, low complexity, simple, pass-fail, use the attribute gauges, and high complexity, maybe you have to use the variable gauges. So, a little graphic here. On the top side, you're going from low to high. In terms of volume, when you have low volume, you could use anything. It may not matter. Low volume, low complexity, either one. That's kind of the no-brainer type of checks. So go ahead and use whatever you're comfortable with, whatever you're confident in. For the high volume but low complexity, grab your gauge pins or your drill blocks, set up a go no-go. For your low volume but high complexity, that's probably going to lend itself to a variable gauge inspection. And you've got a lot of tricky features to do. You might need to use a caliper for 30% of it, a micrometer for 30% of it, a CMM for the rest of it, height gauges, whatever. So those all are those variable checks where you're going to be spending a lot of your time. Those go no-go checks can be very quick, but the variable checks are going to be more time consuming. And then when you get to high volume and high complexity, this could be, think about a car manufacturer doing engine blocks. They crank out thousands of those engine blocks, very complex geometries. That might be time for some sort of automation, CMM. Maybe you still do a few checks manually, bore sizes, but when you're relating feature sizes and locations to other features like this hole to here, this hole to here, this slot relative to the side, whatever the print says, that might lend itself to an automated CMM inspection or another type of robotic inspection. Just think about it. When you're starting to plan out your work, think about what's the best tool for the job. That's what I want you guys to think about. And as you get more experience, as you use the tools more often, you're going to have that natural feel develop for it. So quickly, this is me on my last slide. Look at some other applications. Because it's more than just gauge selection and volume and resources. As I mentioned, there's sampling plans that factor into variable and attribute. And when you get that, you get a control chart. So there's an example of a control chart on the bottom of that slide there. You can track, what your output, your process output is. So top line there is your one extreme of your tolerance, bottom line is the other extreme, and the middle line is the nominal. And you want to track, are you staying within the zone, but also how much is it varying? Is it skewed one way or the other? Is there a bunch on the top side and then a bunch on the low side? Or are they all clustered around the middle? Companies can use this information to really improve their processes. So that might factor into you might really want to use your pin gauge for go no-go, but the company might be more interested in a real number, in which case you might have to use a micrometer or a CMM. But either way, there's more applications than just the measurement. So just be aware of that. You may be one day required to use a specific gauge because of the data they want to collect. So anyway, I think that's it for me. Yep, that's it. So once again, I want to thank Laney College in Oakland, the machine technology program, for letting me use some parts and some gauges here. And I recommend, if you're in the Bay Area, check that out because it's a great program. And I want to ask you guys to check out the website, practicalmetrology.com, where you can find more videos, resources, and generally just hopefully I'll have more content on a regular basis. So thank you again, and I'll see you at the next video.